You know, in machine learning, we're always talking about data, algorithms, all the technical stuff. But there's this other huge piece of the puzzle we don't always put front and center: time. And it turns out how a model handles time, that can be the make or break factor. It really boils down to this one question: are we learning from a single, frozen picture, a snapshot, or are we learning from a river of data that never stops flowing? So let's start with this big question. Does all data have an expiration date? I mean, think about it. For some things, no way. A picture of a cat from, say, 1985 is still a picture of a cat today. The data is timeless. But what about last year's stock prices? If you try to use that data to predict the market today, yeah, that would be a total disaster, right? So this one simple idea, does the data expire? That is the key to this whole conversation.
Okay, so first up, let's dive into this idea of learning from a snapshot. This is where we talk about static machine learning. And really, it's all about learning from one single fixed moment in time, just like taking a picture. The reason static learning even works is because the data itself is just stable. You know, its basic properties, the things that make it what it is, they just don't change over time. It's kind of like learning the rules to a board game. Once you know the rules, you can play that game today, tomorrow, next year. The rules haven't changed. You can totally trust that the data is still going to be relevant.
And the process for this? Oh, it's super straightforward, which is one of its biggest strengths. Step 1, you grab your data, your snapshot. Step 2, you train your model. And here's the key part: you only have to do it once. And then, step 3, you can apply that model whenever you want. It's basically a train once, use forever deal, which, for the right problems, is just incredibly efficient.
Here's a perfect example: classifying animals in photos. I mean, a lion is always a lion, right? A lion in a picture from the 1950s looks pretty much like a lion today. The things that make it a lion, the mane, the face, all that, those features are constant. So, a model you train to spot lions can look at an old black and white photo or a brand new one from your phone, and it'll work just fine. In a way, the model itself becomes timeless.
Okay, but what happens when time doesn't stand still? When things are always changing? Well, now we're flipping the script and entering the world of dynamic machine learning. Here, we're not dealing with a static snapshot anymore. We're learning from a constantly flowing stream of information.
So, dynamic learning, you'll also hear it called time series learning. It's built for data that's basically alive. It's always evolving, always changing. In this world, it's not enough to just know the past, because the actual rules of the game can change from one second to the next.
This quote really just hits the nail on the head. A model trained a year back will be completely useless to predict the weather for tomorrow. And it's so true, right? Can you imagine trying to use a weather model from last spring to predict a hurricane tomorrow? It's absurd. The patterns have all shifted, the conditions are totally different, that old data has expired, and your model is basically a paperweight.
So, in the real world, what this means is that training is no longer this one-time thing. It becomes this constant cycle. You can see it here. You train your model in January, but then in February, you've got new data, so you have to retrain it. Then you do it again in March, and on it goes. The model has to keep adapting to stay relevant. It's never really done. It's always a work in progress.
All right, so we've seen both sides now, the snapshot and the stream. Let's put them right next to each other, head to head, and really break down what makes them so different.
This chart really lays it all out perfectly. Look at the static side, the snapshot. The data has constant properties. The training happens once, and the model's state, well, it never changes. It's locked in. Now look over at the dynamic side, the stream. The data is time-sensitive and always changing. Training is continuous, and the model's state, it's always changing as a function of time. And that right there, that's the absolute core difference. This idea of state. Is your model a fixed, finished thing, or is it a living, breathing entity that evolves? That's the whole ballgame.
Okay, so snapshot, stream, static, dynamic. Why does any of this actually matter? What's the so what here? Let's get to the big takeaway.
Well, it matters because if you pick the wrong tool for the job, your model is going to fail, period. Trying to use a static model for something like stock prediction, that's like trying to take one photograph of a raging river and claiming you've captured everything about it. You completely miss the current. So the bottom line is, static models are for your stable problems like image recognition. Dynamic models are for pretty much anything that evolves, like weather or stocks. And it all boils down to that one idea we keep coming back to, the notion of state. Is the model fixed or is it fluid? And hey, just a special note here, reinforcement learning, where an AI learns through trial and error like in a video game, that's always dynamic. It just has to be.
And all of this leaves us with one last, kind of huge question to chew on. Our world is creating this absolute tidal wave of live, streaming data every single second. So, in a future that's defined by this constant flow, what happens to the good old-fashioned snapshot? I mean, are we heading towards a world where almost every single problem is going to need a dynamic, always-learning solution? It's definitely something to think about.